Welcome to another informative video brought to you by Otruo. The last time, we ended off looking at the last graphical programming language in this series, which is sequential function chart. The way this programming language were used was discussed in detail. Finally, we ended off looking at its application in an industrial settings. In today's series, we will be looking at statement list programming. The way this text-based programming language is used will be discussed in detail, coupled with a practical example. Stay tuned. Statement list, which is fondly known as STL. It is a textual-based programming language that are also used during PLC programming. Its syntax for statements is similar to high-level assembler language. It consists of a set of instructions followed by addresses on which the instructions act. Of all the programming languages out there, STL is the closest to the machine code MC7 of the S7 CPU. This means that by using it to program S7 controllers, you can optimize the runtime and the use of memory. This programming language has all the necessary elements for creating a complete user program. It contains a comprehensive range of instructions. A total of over 130 different basic instructions and a wide range of addresses are available. Now, in order to fully understand how this programming language works, let's write a simple STL code for us to see. I will open my TIA portal applications and write my STL program accordingly. So to begin with, we will create an IO tag list for our program. This will make our programming to be very easy. That way, during program writing, the IO tags can easily be referenced. So, the start and stop button, height sensor, the main contactors, the motor thermistor, and the backup sensor are all programmed as follows. While the motor contactors and warning light will also be programmed like this. One thing worth noting is, we want the indicator light to come on when there are bottles of irregular height passing through. Now there is need to create a block that will house our program. We will select STL from the programmed list. Now during STL program writes, there are certain elements that is usually taken into consideration, which are O and A equal, etc. Our elements are called bit logic instructions. A document provided by Siemens can be handy here. You can check the link in the description below, or a little Google search can be handy here. So based on what was said in page 13, bit instructions work with two digits which are 1 and 0. I believe you should know what that means, Hendrix.
Yeah, Laura. 1 means when there is a 24-volt signal and 0 means when there is 0-volt signal.
Perfect, Hendrix. So these two digits are called binary digits or bits. So let's quickly look at the examples here. A is the combination of two signals. So before there will be an output, signal 1 and signal 2 must be active before the output will be active. AN is a NOT. This means it is normally close by default. O is known as OR. That is, either if signal 1 or signal 2 is needed before the output can be active. And so on. Again, do you want me to print out the results? I'm just joking though. We are not going to print out anything here. Our results will be seen when we simulate our program. Perfect. Again, one thing worth noting is, STL programming is not only used for discrete signal which are 1 and 0. It can also be used for continuous signals as well, which are 4 to 20 milliamperes, 1 to 5 volts, and 1 to 10 volts. Now let's start writing our STL program. Again, what we want to achieve is, we want a situation whereby, when the start button is triggered, the contact should be true, and it should continue to remain true when the button is not pressed. Because we are not using a spring-loaded button. So this ladder diagram will be represented like this. Or start button. with or process active and stop button, and warning light equal process active. The condition and warning light is as a result of some manipulation in the coming network. So basically what we want to achieve is, we want the irregular height check to be a condition for the main contact. So when a bottle of irregular height is detected, the whole process should stop. Now, the main reason why I said the whole process will stop is because the process active will be tagged to all the networks. Well, I want the all network to only become active when the start button is pressed. That way, the activities or the behavior of the conveyor system will be synchronized. The next block is for the first conveyor motor. Here, the process is active, and the backup sensor and the thermistor will result in a running motor. For the second conveyor motor, the normally open of the main contact, and the thermistor and the process active will result in a running motor. Again, what we want is, the second conveyor should only be active when the conveyor is running. The rejecting conveyor. Also, process active and thermistor and a height sensor will result to a running rejecting conveyor system. While for the warning lights, the height sensor and normally open contact of the contactor of the rejecting conveyor will result in the coming on of the warning light. Just like what was discussed earlier in the first network. The normally close of the contact reference these. And it depends on these conditions, and the over system also depends on it as well. Now, I will drag this block to OB1 for program calling. Likewise, I will also download this code to our simulator and let's see how it will work. Now when I triggered the start button, the conditions are all set for the network. However, when I turn the conditions of the start button to false, which represents when the finger is removed from the start button, the network output is still active, because the OR process active is acting as a retainer. Again, this will be discussed in one of our upcoming series. Now, when you look at our program, you will see RLO. The RLO means the result of logical operation. This stores the result of a logic operation string or comparison instruction. This RLO bit is the status word bit 1. The first instruction in a segment checks the contact signal state. That is, the RLO will be set to 1 if the check is executed. Now to fully understand what it means when I triggered the start button and when all the conditions are not active, the RLO is set to 1. The reason is that there is no additional contact or instructions before the start button. Now, when I repeat the same conditions here, the RLO is not set to 1, which is because the contact or instructions before this contact are not active. Overall, Statement List Programming Language is a very easy program to learn and understand because it offers some flexibilities that other languages don't have. Over to you, Andrea.
Perfect, Laura. Statement List Programming Language is a very easy programming language to work with during programming. Apart from the features mentioned by Laura, this language uses less memory as compared to the other programming language. Because all the instructions and conditions are represented in a text format. This will in turn reduce the cost of installations. Because of its relatively low memory consumption. Again, it is also a very flexible programming language. Because all the instructions can easily be copied and pasted in the programming interface during program writing.
Perfect, Laura. Which means, I can write a program on my notepad and after writing, the program can be sent via email. And it can be pasted into the programming software. Perfect, Laura.
Yeah. Now let's do a quick recap. We started off looking at what statement list programming is. The way this program are used during program writing was discussed in detail. And finally, we ended off looking at its practical application in the conveyor settings. In the coming series, We will be looking at instruction list programming. The way the program is used during PLC programming will be discussed in detail. Hope you have learned something new today. See you in the next one.